Thank you for joining us for Beyond Transactions, Why Graph and AI is Redefining Financial Crime Detection. I'm your presenter today. I'm Victor Lee, Head of Product Marketing here at TigerGraph. And we're going to get right into it. So, you all joined us today to hear more about how financial crime is evolving. And one of the unfortunate things is that it's growing. It's growing fast. It's at the rate at which it occurs and the total volume. The cost to businesses, when you talk about things like credit card fraud, 7% of every dollar spent, 7 cents of every dollar is lost to fraud. When you look at the total market, the total business, 40 billion dollars of losses globally. And it's occurring fast. Currently, about 1.5 million transactions per minute need to be handled, with some fraction of them. Every one has to be checked to see if it's fraudulent or not. And with electronic transactions, that's only getting faster. Now, why is fraud growing? Well, it's for a certain number of people, it's lucrative, but it's because a lot of technology is being used. And so there's a technology arms race between the criminals and the financial institutions and retailers. On the fraudster side, they're using technology not only to create better fakes of things like ID, but to disguise their tracks. So one is referring to particular pieces of information, and the other is referring to the process. So the process is also being disguised. And they're using technology to go to scale, to automate more of the operations, to generate more cases, more fakes, to submit more transactions, a lot of automation. Banks, on the other hand, are also using technology, and Tygraph is helping them to uncover those tracks, to detect the fakes, and to also operate at scale. So it's it's fire versus fire. So the key types of activity are networked activity and the use of AI, and we'll be talking about both of those today. So first, the network's nature, and this particularly applies to money laundering. It can be used in other types of fraud, but it's very clear to see the examples with money laundering. So you have the case in general. What is money laundering? It's when you start with so-called dirty money, money that was obtained through some sort of criminal activity. And the idea is to, quote, wash the money so that its origin is no longer visible. The people who are accepting it for transactions, etc., the bankers who are holding the money can't see that it was obtained through illegal activity. And the way you do that is by transacting it and doing it enough times in enough ways that people lose the trail. So you often start with structuring where if this is a large amount of money, you first need to break it up because large amounts of money are conspicuous. So, but smaller amounts are not. And so you split it up and then you often send it to these various accounts and then they will conduct transactions. Some of these will be purchases. Some of them will be legitimate purchases. Some of them will appear to be, but there's collusion going on, and you're passing the money off to a partner. Um, and and some of these are just cash transfers, etc. It can be a variety of different things. But so the money gets spread out and then eventually gets integrated again. And so the process of just these different, you can see it's literally layers of transactions. So it's called layering. Another type is circular washing. Here, the money went from A to B. Here, they simplify it. Money starts in A and comes back to A, where this account itself looks to be okay. It's just the fact that it's holding some money that, again, that was acquired through illegal activity. You send it through a bunch of transactions, and again, the fact that nobody is keeping track of the full trail, they don't realize that it's going in a circle. And the parties that are involved along here are called mules. Mules can either be in on it or unaware, but in general, the general term is a mule. where they're just the money passes through them over time. So individual transactions look innocent. That's the key. Individual transactions look innocent, but when you see the network of activity, that is the clue that money laundering is occurring. Now, criminals are also using AI to amp up their activity, to make more convincing fakes. You can, but whether it is the visual face there, whether it's the information, they'll take, little bits of true information, make up some other, combine it. The thing is, you can train an AI system to just generate thousands of these. It used to be something that people would have to, an expert would have to work on carefully, or they would have to write a program to do it for them. Now you just talk to an AI and ask them to do it. At the same, so it's that automation. It's both making the fakes, automating the activity, automating not just the creation of these, synthetic fake information, but also automating, it can tell you, do this set of transactions. Now, you may need people to actually conduct some of them, but the AI will make the plan for you, and in some cases, actually conduct the transactions. And again, maybe you've been receiving phishing attempts, and maybe they're getting better and better where they're looking more and more authentic. And again, it's because a lot of them are created with AI, where you simply instruct the AI, make this look really good. So, how can we fight this? How are banks fighting this? Well, turns out that if the activity is there in the network, you can use a graph database query or algorithm to spot it. So you have a sea of transactions. What we're showing here is just one subset of what exists within the whole transaction graph. But you write a query which is looking for, find a source and sink pair such that there was this structuring activity. It looks like it's fanning out like that. There is this layering, and then there is the integration. And you don't even have to tell it the exact number of layers, the exact horizontal spread, the exact lateral depth. You can write an algorithm that in general looks for this pattern. So that's something you can do with traditional query language, and AI can help you with that. You can also write queries that look for this circular pattern, and that's actually pretty easy. You do have to filter it to say, what is sort of a reasonable loop size. Just sending money back and forth. You loan money to somebody, they pay you back. That's not necessarily suspicious at all. Um, and these have to be moving forward in time, and the amounts have to be roughly the same, probably a little bit of decrease as each person is maybe taking a little bit of a cut. And you could see how these could be combined. This doesn't have to be just a single transaction. This could be spread out and structured to make it harder to spot. But again, if it's in there in the graph, you can put all these transactions in a graph database and use graph queries, standard algorithms, more custom queries to find this. Again, you can use AI to help write these queries. You can also use it to automate so it's continually checking, and also to not just look for the pattern, but to look for things like, is this a sudden change from the background normal activity? So there are tools, TigerGraph is working with banks to help implement these, and we'll talk about that. And again, as I said, besides that sort of money laundering, there are other types of fraud. There are, credit card fraud is usually more straightforward. It doesn't have that big network, but there are connections because often the big players aren't, they didn't just steal one credit card. They stole, it used to be tens or hundreds. Again, with automation, I shudder to think how many they're handling. But there usually are things that you can trace back. Some of the information has to be real, and it all leads back to those things. So they may have had there's one actual IP address involved. They may be using VPN, but still, there's a smaller number of IP addresses. There's a smaller certain number of mobile devices that are actually being used. So these different transactions can be traced back to, do you see a clustering, a conjunction where a lot of the same IP addresses or mobile devices are being used? And when you look at the pattern of activity, it's suspicious. Sometimes you'll also be able to trace back to phone numbers and email addresses. Again, when you see a clustering, there all these different transactions accounts, these accounts are all leading back there to a small clustering. And when you look at the pattern, it would be really unusual for a legitimate individual to be engaged in that spread of activity. That's another sign. So these two types of looking for the money laundering patterns and looking for the hidden connections of who is behind this activity. Those are both powerful tools of graph-based analytics supplemented with AI that can help to catch the fraudsters. TigerGraph has been working with financial institutions from its beginning to help them address this problem. And a typical result we've been able to achieve is to help them, excuse me, decrease, actually increase their fraud detection by 20%, catching 20% more of fraud. Um, it's often also the automation, the speed of graph analytics, and the visual nature increases the efficiency of fraud investigations. One customer tells us 300%. Our larger customers are saving $100 million per year. It's relative to the size of the institution and where they were before they started using TigerGraph. And again, those larger institutions have data sets on the 10 terabyte range. All of this works in real time. It's handling, it's both can be training a machine learning model and checking every real-time transaction. Again, with some customers with credit card processing, it has to be in the range of 80 milliseconds to do that check. One of those large customers is JP Morgan Chase. They are the largest credit card issuer in the United States, and they're saving over $50 million. Again, they had a very good system, but I said the the fraudsters are using technology too. So it's a moving target. You have to keep advancing. So they saw that the next step was to use graph analytics, and they needed a scalable, very fast graph. And so what we did, again, they formed a graph like we showed of the transaction activity along with information about their customers, about their merchants, which are also represented as relationships. And they use graph algorithms and graph queries to find some of those patterns we talked about. The ring, the structuring, but there are other things. They're looking for communities of activity and computing page rank. Uh, Dozens of these features were used to supplement their machine learning features to make their machine learning models more precise, more accurate, and to add explanation to what's happening, which is always good for investigators who uh, want the banks to explain how are they doing money laundering, how are they doing fraud detection. Nubank, which is the largest digital bank in Latin America, was seeing a problem with mule accounts. We talked about mule accounts earlier. So they were facing 9,000 scam reports from their customers each month for nearly $2 million a month. So about $25 million a year. Their previous system was not able to provide the accuracy. By using a native graph-based solution, using similar techniques to what I talked about with JP Morgan Chase, they were able to catch twice as much fraud, reduce the number of false positives. Again, so most of this money was then saved. So they're recovering, tens of millions of dollars per year. So again, yeah, as I said, avoiding those losses from fraud, serving the needs, satisfying 65 million households with fewer attempts. So, the in this case, the not just the customers who were innocent were feeling victimized because their accounts had maybe been taken over, they were getting locked out, or money was being stolen from their accounts. So this was not just helping the bank, it was helping their customers. So that was amazingly done, all done with more traditional AI being machine learning. Now, with generative AI, there's ways to make this even better. You can assist, again, as I said, you can use the AI to keep up with the different patterns of activity. We worked with our customers to write these on the order of 30 different graph features. They're targeting particular patterns of activity, and those patterns change over time. So the customers have to review the patterns, and AI can help automatically look for anomalies and discover new patterns to check. It's also when there's investigation, it can help guide the investigations, suggest what needs to be done, and work agentically to actually go ahead and do those things for them. It can, in that same line, it can offer advice on what should you be monitoring, uh, what to do when something goes wrong. It can also help the financial institution automatically comply with some of the regulations they have. It can say, okay, this needs to be done using agentic AI. It can actually just put that in place. And for both external customers and internal customers, you can have chatbots, which allow questions to be answered by just using natural language questions. So giving better customer satisfaction and more efficiency for your internal employment employees. Again, these these investigators can have these bots, which it's much easier for them to work. And then with the graph can actually perform the work faster, and the agentic AI can handle more complicated, more less clear tasks, or more goal-oriented tasks rather than specific actions. So there's a lot of way that AI can and is helping fraud detection. And the way that graph is helping to make the AI better itself is through um, this balancing of needs of pros and the advantages of large language models and the advantages of graph, how they complement each other. And so by using both, you get a more powerful AI. Large language models are excellent at taking very abstract, complicated, so-called unstructured information and making it usable. And that's by they creating abstract, so-called embeddings to represent complex information, and building these generative models that sort of predict, well, if you have this, then this is a good response. However, they do work in a very statistical way, and also not very explainable way. These embedding models and these neural network generative models, they can't really tell you why they did something. Um, if you ask a AI agent, it will give you an answer for why these days because they put in a lot of work into it, but it's not in the native behavior. It's actually AI working on top of AI and using multiple models. The tools that things like ChatGPT and Gemini, they are not any single large language model. They are a whole collection of models working together. It's very complicated. If you were to try to replicate that yourself, it's essentially impossible because that's, you know, billions of dollars and thousands of people. So how are you as a company going to build your own AI? Well, it's because you're going to take a different tact. You're going to use a tool like a graph database to help you out. Because a graph database takes some of this work that's the LLM isn't very natively good at, but the graph database is good at. what the graph database is good at is dealing with if you have specific knowledge, contextual information. So it's more modest, it's more focused, and sometimes you have very specific facts. And those specific facts are more structured. You can store that in a more conventional database, but it's relationship based. So you have deterministic information and deterministic queries. And due to the nature of the way that it's storing relationships, it can just answer why did it do something? It's because of this set of connections. So it's a great combination where they complement each other. You can store both your structured information as in very traditional database techniques, as well as unstructured information. So it could be regulatory guidelines, economic reports, fraud alerts, by feeding that information to an LLM, which transforms it into an embedding into entities and relationships. So you can actually ask an LLM to take your unstructured documents and create a graph for you. And it will identify the major concepts and things that the major important nouns in your documents. It will identify relationships between those things, and it will create a graph structure. And that complements the structured knowledge that you have. So how does this work together with or work within an AI system to make it better? This is using a technique called graph rag. So typically you have a human. It doesn't have to be a chat bot. It could be more of an agent, but the human is making a request. And first you parse that request to encode it, to chop it up into pieces and encode it, and then you send it to your graph, which looks for relationships. So it takes the things that were mentioned here and it looks for similar things that it knows about and it looks to what is related to that topic, not just in the vector DB sense of similar. We're talking about any sort of connection. It could be talking about different types common connections. It could be ownership, it could be a parent-child relationship, it could be you know um, responsibility for. It could be, depends on all sorts of different types of relationships, as well as traditional searching for document chunks that have similarity. And then you send that back to enhance, add context. So goes in, starts with the original question. You go here to get more context and you send that back. So you now have richer information. Then you ask your LLM to answer your question with the added information, added guidelines about how the question should be answered, how it should not be answered, based on the organizational requirements. And that it's that added step, is so-called graph rag, graph retrieval augmented generation, that enhances the performance of your AI. So I'm going to talk about one more thing before we jump to a demo. So just to sort of recap, we talked about the nature of fraud today, where they're using both AI and networked activity. Banks can use graph techniques to detect that, and they need to, otherwise they will be missing out. Tygraph has succeeded with helping banks in production to do just that, and how AI is changing the game with more automation and creating creating better fakes. But again, you can use the AI to detect that. And lastly, how graph can improve the quality, improve the relevance, reduce hallucinations in AI. Now, as a product, TigerGraph, besides having integration to AI, we've done something to our database itself to make it more AI friendly. And that is, we are now a hybrid database storing both graph and vectors information. So vectors, as you may know, are designed, this is holding the type of encoded information that AI uses. or neural networks use. So they store their information as these numerical vectors, and you need to be also to search for similar vectors. So tygraph has that vector database capability. We have our existing scalable parallel performance graph, and the two are tightly integrated, so you get the performance and scale advantages of the graph in the vector database as well, and they're tightly coupled so that when you're doing things like graph rag and you need to do both graph search and some vector search, it can do the two of them together much more efficiently than having separate systems and with the performance advantages of TigerGraph. And to talk about that whole process of how we helped companies like JP Morgan Chase, how we helped Nubank, we actually have a solution kit which gives examples of sample transaction data, graph model, and queries. Those graph feature queries I talked about are all included in this kit, which you can get from uh, Savannah, TigerGraph Savannah, our cloud service. So what I'm going to do now is show you an example of how that solution kit might look with this is not the sample data in our sample kit. This is another set of data because I think this one's even more illustrative. So this is a typical dashboard that a bank might be using on its fraud team, and they're measuring how good a job they've been able to do at detecting fraud. And these are two specific measures of prediction accuracy, precision and recall. Recall is the number of actual fraud, excuse me, the percentage of actual fraud being detected, and precision is the percentage of transactions that the system labeled as fraud that were labeled correctly. So what percentage of the ones that it said were fraud are actually fraud? What percentage of actual fraud is being detected? So week by week, the performance varies a bit, but it's been averaging around this high, mid 50s to low 60%. Not great, but this is where some of our customers do, in fact, start out if they're not using Graph. This is another measure of performance. It's what are your prediction errors in the two directions of uh, did you predict it was fraud and you were wrong, or did you predict it was not fraud and you were wrong? And again, so this was sitting at 53 and 37. So ideally, this should be 100 and this should be 0. So there's obviously room for improvement. And over here, making some assumptions about what does it cost each time you make one of these errors, we come up with the business is losing on the order of $6 million a week. This data is weekly, not monthly. So that dashboard is showing how are we doing? How are we doing over time and helping us spot the problems. Now, the graph is saying, okay, you've got transaction data. You have data about your merchants. You have data about your account holders, the parties, and their credit cards, whether you're the credit card issuer or just handling the transactions. And we offer a graph model to show how can you store all this information as connected data. So this is representing the transaction itself as an event. Is how it's the amount, when did it occur, and then these other things are information that we compute from the processing later on, the graph algorithms. If you have a merchant, again, what's the merchant name, ID, some other things that we compute about it. The other parties, the account holders, just an ID, gender, date of birth, name, but some other thing, is this fraud or not? And the is fraud or not is because you need training data to train a machine learning model. You need some data from the past where you knew whether it was fraud or not. So this whole graph showing how things are connected. You load the data into the graph. Then you need to do those queries. And I'll show you just a couple examples. The first one is in a category called community detection. Community detection looks at how things are connected in the graph, and it's finding where there are natural groupings based on interaction. So it's not anything that was known in advance. If people change their behavior, then the communities change. It's all based on behavior or relationships. So this Louvain algorithm finds clusters of nodes that are relatively well connected based on that activity of based on those relationships. Because it turns out fraudsters work within communities just like everybody else. Another important algorithm is PageRank, straight from our graph algorithm library, our library of over 50 algorithms. This is finding ones that are, quote, influential within the node, looking at that pattern of activity in a different way. We're not looking for are they in a group. We're looking for who is having the most impact on others around them. But it's this type called influence where people, if the activity is directed, the activity is directed towards you. But it's not just looking at your immediate neighbors, it's looking at recursively at sort of an infinite chain of layers. Excuse me. So it's looking at over time who is the sort of the person that more than anyone else activity is being directed to them generates a score. Page rank score, you may have heard it used for web page ranking. And lastly, there's a whole set of these, excuse me, custom queries, which are specifically for this transaction fraud. The other ones were more standard algorithms. This one is looking at if you know the community already, what's the average transaction size within that community? None of these features by themselves point to fraud, but the collection together can tell you. So it's important that you look at the whole collection of things. So the last stage is you've taken your data, you've imported into a graph so you can have the connections. You run these queries and algorithms to generate features that you know about. Now you know these features about the merchants, about the cards, about the parties. You then send those features along with any features that you already knew before using the graph. So this is the graph processing. This is what you would have done without graph. You combine the features. So these are the features that you could get from traditional tabular analytics. These are the features that you can only get from graph. You combine them and you do machine learning training. And this is a Python notebook using classic machine learning algorithms like XGBoost, and also with Tigergraph's Python library, PyTigergraph, and was just walking through that process of running the algorithms, doing some data transform from non-numeric to numeric data, creating training sets and test sets, and training the model, as I said, using XGBoost, uh, and then measuring the performance of the model, and then doing a comparison without the graph features to see what sort of improvement was there. And recall those the two measures I showed you on the dashboard, precision and recall. Precision recall without the graph features, with the graph features. So we're going from 49 to 82%, giant improvement, recall 54 to 89. So let's go back to the dashboard. And this is, using the sample test data. This was data up till the start of start of August. And then 10 more weeks pass. So the assumption is that the graph machine learning was introduced at that previous time, at that start of August, and then 10 weeks transpire. So what's happened is precision and recall have gotten better by that like 25%, getting close to 100. The false positives and false negatives have dropped down to, in some cases, single digits. So huge improvement there. And bottom line for the business, the amount of money that was being lost to fraud has dropped from that 6.3 million to 1.4 million. So, business goal being met through the use of graph enhanced analytics and AI. So, to wrap up, the benefits of using Tiger Graph in particular is that we've been doing this with the US and the world's largest banks for many years and saving them millions of dollars. So the expertise is demonstrated. It's using those graph algorithms and graph queries we have, but executed on an engine that can handle the scale for large data sets, can do it with unmatched speed and handling some of these more complex algorithms. And we now have that hybrid graph and vector capability. So you can integrate Tiger Graph with your AI frameworks, both at the database level, and we didn't talk about it today, but with MCP and other integrations. So to really very smoothly integrate Tiger Graph into your AI. And the bottom line is why to use Graph for this case of financial crime detection, the way Graph plus AI is changing things. Graph uncovers the intentional layering in money laundering. It also uncovers the hidden connections that you'll find in all types of financial crime. So it adds context, it adds traceable learning and guardrails to AI. So not only do you get increased accuracy for your predictions, get higher efficiency, and which ends up saving the organization millions. So thank you for your time, for listening to our presentation, and